Welcome in third module. Here, we will learn about network analysis. What is network? The network is an arrangement of paths that connected to various points where one or several items will move from one point to another. And what is the network analysis? Network analysis is a combination of logical thinking illustrated with a network that contains trajectories of activity and allows for analytical processing. Or the network can also be interpreted as a set of points called nodes and curves called branches with connect contain vertices. For the example, here is the network. The small circle means the nodes, it states an event, and the arrows, it means branches declare an activity. Network notation. For the example, here is the network. The notation from the network G is G and A. N is the set of nodes and A is the set of arcs. For example, N 1, 2, 3, 4, 5 and A 1, 3, 1, 2, etc. Network problem. There are three network problems. First is minimum spanning tree, and then shortest route, and the last is maximum flow. First, minimum spanning tree. The tree means a group of connected arrows that don't form cycles on the network. Spanning tree means a tree that connects all nodes on a network. The resulting network spans or connect all nodes in the network. And how to solve it? First, select one free nodes that closest nodes connection. These two nodes become connected nodes and the rest become not unconnected nodes. For the example, the first node is 1 and the next node is 2. Second, identifies the unconnected node closest to one of the connected nodes, no need to consider binding, and these new nodes to the connected nodes group. After 2, we choose 5. After 5, we choose 7 and 10. After 10, we choose 8. After 8, we choose 6 from 10. After 6, we choose 3. And here is the result. We can calculate the distance.
Shortest path. The shortest path problem or shortest route is a problem for finding the path between the two vertices on a weight graph that has a combined value of the total weight on the graph, traversed with the minimum number. Here the example of shortest path. The picture shows the shortest path or thick line from node 1 to node 5 with line 1, 4, 5 with a total weight of 5. Types of shortest path. Type 1 is the shortest path between two particular vertices. Type 2 is the shortest path between all node pairs. Type 3 shortest path from a particular node to all other vertices. And type 4 the shortest path between two vertices passing through certain vertices. Pathing algorithm. Pathing algorithm is an algorithm used to find a solution in determining the shortest path of a graph. Dijkstra algorithm. Edger Wipe Dijkstra discovered an algorithm to find the shortest path in a graph. This algorithm used the greedy principle, which is used to state that at each step we choose the minimum weight side and put it in the solution set. Maximum flow. The maximum flow problem is one part of transportation to find the best solution that can flow on a network. This problem is a development of the cost problem minimum flow or minimum cost flow intended to minimize costs. Here, the example of maximum flow in the daily life. One is maximizing the company's distribution flow from factories to consumer. Two is maximizing airflow in the system. Three is maximizing the flow of vehicles in the transportation. In general, the maximum flow problem can be described as follows. One is all flow through a connected and directed network that starts from a single bond called the source and ends at the point called target. Two, the other node is the delivery path, or the nodes are symbolized by A, B, C, D, E, or 1, 2, 3, 4. And last, flow-through search only permitted in the direction indicated by the arrowhead with the amount of flow given by the magnitude of the arc. Steps to solve maximum flow. Step 1 is find a path from the source node to the same node that has positive flow capacity or in the direction of the flow for each arch of the path. Two, look For the smallest arc capacity, PF, on the path selected in step 1, increase the flow on the network by sending a number of PF on this path. Step 3, on the path selected in step 1, reduce all arc flow capacity in the flow direction with PF and add all arc flow in the direction of the flow opposite to PF. Next, go to step 1. So that's all from us, the explain of network analyzing. Thank you.